All right, so today we're going to be talking about the lymphatic system, and actually what I did is I divided it in two parts. Lymphatic system is straightforward. Just reading on those the structures. And it was just like, it's just like the lab. So today what we're going to do, we're going to describe the general functions of the lymphatic system. We're going to list the major lymphatic vessels, the major classes of lymphocytes, and the functions of each one. Okay? So there are mainly two types of lymphocytes, right, that are going to be here. And what are they? What do you call a thing that is square and you watch it almost every time in your house? T, but this B is, the B, not the V. So TB, so lymphocytes T and lymphocytes B. These two lymphocytes, right, T comes in different flavors, right? We have a natural killer cells, or also known as the TK cells. We have our T helpers, 1 and 2. We have a T cytotoxic, that's TC. C is for cytotoxic, means it's going to release a toxin and it's going to destroy the cell or stimulate the cell for autolysis. And the next one is going to be TS, and S is for suppression. Okay. The role of natural killer cells or TK cells, it's not within the T sites, right? So we're gonna talk about the natural killer cells and not being part of the actual T cells, although they are part of that family, right? But they work in a different way. So that's kind of like an exception. The B cells. What are different type of B lymphocytes? So this B lymphocytes, the B cells that are found in the blood plasma, what are they called? They're called cells that are found in the plasma. What do we call things that are found in the plasma, guys? Anybody? They're part of the bloodstream, correct? So they are inside the blood, so blood plasma. Now, B cells comes in different flavors, and the mnemonic is the D game. That's the mnemonic, D game. What's the name of the B lymphocytes that are found in the plasma? Plasma cells. Okay. Now, the B cells, they are going to create multiple amounts of proteins, and these are known as immunoglobulins. Why do we call it immuno? Because immuno comes from the what? Immune system. And globulin, what is globulin? Globulin is a protein. So there are proteins that work as part of the immune system, right? Destroying antigens. So you have, for the D, you have IgD. For the G, you have IgG. For the A, you have IgA, and you get the cycle, right? So all you do is you put Ig, and then you put the letter. So the mnemonic is, again, D game. So there are two types of major lymphocytes, and those are T's and B cells. What is the main function of the lymphatic system? Lymphatic system is what? To maintain, produce, distribute lymphocytes, and as well, since you have lymphocytes, they're part of your white blood cells, right? Because remember, what are the white blood cells? Do you guys remember the white blood cells that we went over? What was the mnemonic? Mom. So the one I give is Mom never let me eat beans because I get gassy and bloated. So M is for what? mono, neutrophils, lymphocytes, eosinophils, and basophils. Now, where are we talking about? We're talking about only what? The lymphocytes. And we said lymphocytes are either what? T's or B's. So when I say white blood cells, that's what I'm referring to, right? Because they're part of your white blood cells. Okay. So definitely there is a defense against infections. Yes. As well, it's going to collect any excess amount of fluid that is in your interstitium, so in between your tissues. So it's going to collect it, and it's going to allow that fluid to return back to the circulatory system at the level of the right atrium, where all the venous blood returns, correct? We also are going to distribute nutrients, including waste and including hormones. Why? Because if you're collecting the fluid that is in between your tissues, that fluid is a filtrate of the plasma, but without red blood cells or major proteins, correct? Because they cannot go through. That's what we said, because the sinusoids are really small. Now, they are going to be collected, and not only the nutrients, but as well as waste products. So these nutrients and waste products are going to return back into the heart, and of course the waste products will be taken out by the liver and the kidney, and then pee it out or poop it out in your body, right? Or even sweat it out. So lymphocytes, the main thing. Lymphocytes are going to be created where? On your red bone marrow. Red bone marrow creates your reds, your whites, and your platelets. Remember that we talked about that, right? So red blood cells, white blood cells, and platelets. That's what's going to be created there. And you can actually see it. So you have a cell, which is known as the hemocytoblast, and that is going to stimulate the production of your lymphocyte stem cells, and hemo means blood, cyto means cell, and blast means creation. So that is a pluripotent cell that is able to create your lymphocytes. So lymphocytes are what? Your B cells and your T cells. Now, B's and T's are created in the red bone marrow, right? The same thing as your natural killer cells. The T's, on the other hand, okay, they are going to be sent out through the bloodstream all the way into your what? Into your thymus. At the level of the thymus, that's where they are going to be exposed to the tissue of your body. In this case, it will be the tissue of the thymus. And if they were to, if they pass the test, means you expose them, and if they recognize it, but do not kill your own cells, your own tissue in the thymus, then they're able to be what? To graduate. Graduation means they become now mature. Another word for mature is what? Immuno. What? Competent. There's two words, right? Competent or incompetent. If you're competent, you get to keep the job and you get to keep your life, correct? If you're incompetent, it doesn't matter how many titles you have, you get to do what? You get to do nothing. They're going to fire you right away, correct? So, immunocompetent or competency means that the cell has matured and now is capable of doing what? Whatever role there is in their body, correct? Which is fight infections or antigens. So these T cells are going to give us what? These T cells are going to give us a cell-mediated immunity. What is a cell-mediated immunity? They're going to bind directly to your cells. So that's what a cell-mediated immunity means. Now, on the other hand, you have your B cells. Your B cells are created on the red bone marrow, and sort of the way they get mature, okay? And as they mature is because they've been exposed to a antigen, and this becomes a antibody-mediated immunity. Why is an antibody mediated? Because you need to create you need to create an antibody, right? So what antibody will you create out of the B cell? That's the antibody that you're creating, hence the name antibody-mediated immunity. Which one do you think is faster or shortest? So out of these two that I give you, A or B, which one is the fastest? A cell-mediated or an antibody-mediated? So which one will take faster effect? Something that binds the cell or something that needs to create something else? So this will be the fastest, correct? And this one will be the slowest. Why slowest? Because once you get exposed to the antigen, then what do you have to do? You have to create the D game, right? One of those immunoglobulins that is then going to bind to a specific antigen, correct? Yeah. And now, last but not least, we have the natural killer cells, which I put it inside the T's, but they work by themselves because they're all around the place. Why are they all around the place? Because they are the main surveillance cells, right? They are the ones, they're the cops that always are going or doing runs throughout the whole body. Every time they see something that does not belong to the body, what do? They kill it. That's why the name is natural killers, because they're born to kill. Okay? Now, all of these three, mostly between the T's and the B's, they are going to go where now? Once they are mature and immunocompetent, they are going to go to your lymphoid organs and or tissues that you have in your body. And that is including what? Your lymph nodes, right? That's including your lymph nodes. And as well as your spleen, and of course other tissues. Okay. So how do we collect it? We said that is not only working as immunity, but also to collect. So what are you collecting? Well, you're collecting the interstitial fluid, okay, that is from the circulatory system that was left, right, in here, in your interstitium. So how much of that is actually collected? So the blood and the capillaries, right? Remember we talked about capillaries, hydrostatic and oncotic pressure. They are pretty efficient. They collect up to what? 85%. Now, only 15%, more or less, which is about 2 to 4 liters a day. That's kind of 2 to 4 liters a day. That's quite big, right? In between all the tissues. So that is going to stay within the tissue. So if you leave that there, you're just going to get what? Inflamed, correct? So that is the part that is going to be collected by whom? By the lymphatic capillaries. So you have capillaries from your blood, and you also have lymphatic capillaries, which are these things right here, right? All these things are lymphatic capillaries. Okay. The next one is the distribution of nutrients, right? That we covered. We said that to distribute nutrients, waste products, hormones, right, to the circulatory system. So not only whatever is left in the interstitium, but as well as when you ingest food. When you ingest the food, you're getting what? Nutrients into your body, correct? And that nutrient needs to be absorbed into your bloodstream. How's that going to happen? Well, most of the nutrients are absorbed through the capillary network, so the blood capillaries. Now, there's only one main thing which is your fats, your fatty acids. Your fatty acids are mainly absorbed where? On this green structure right here. And that structure is known as the lacteal. So that's the one that's going to absorb your lipids. So lipids, fatty acids, those will be absorbed especially at the level of the lacteal. It cannot be absorbed anywhere else. Your sugars, your proteins could be absorbed in the capillary network, but the lacteals only absorb lipids. So if you don't have lacteals, what's going to happen to the amount of lipids that you can absorb? None. You're going to have diarrhea almost every day. Does that make sense? Because the fat is actually a lubricant, right? The more fat you eat, if you're not absorbing the fat, then that's just going to make your intestinal peristalsis and movement increase, right? So that this example right here, it overlaps. This is immunity. This is going to be actual part of your lymphatic system, and it overlaps as well with your digestive system. So you're going to keep seeing this over and over. So what is the overall lymphatic system, right? A summary of everything. The first thing is that the lymphatic system is 2-in-1. 2-in-1 means that they are semi-independent. It says semi, right? They still depend on each other. Now, they are composed of your lymph, what is the lymph? The lymph is the fluid that is that's collected from that interstitium. We have plasma, right? The plasma is the one that goes in the interstitium, yes? 80%, 85% of that, it gets reabsorbed back into the blood capillaries. Whatever is left, that 15%, is still interstitial fluid, right? When that is picked up by the lymphatic capillaries, then the name changes from interstitial fluid, right, to what? To lymph. But it's the same blood plasma that you have there, which now has a little more waste products, correct? Now, lymphatic vessels. So, lymphatic vessels, you have different types. You have the capillaries, which we talked about, right? Those are the ones embedded in between your blood capillaries. You have your collecting vessels. You also have trunks, and you also have little ducts. If you think about the trunk, just think about the trunk of a tree, right? And then you have the ducts, okay? So you have one main trunk that divides into. So in other words, this is the order, right? We're gonna go over this one. Now, the next part of the system, right, it's going to be the lymphoid tissue. So a lymphoid tissue includes what? MALT, which is mucosa associated lymphoid tissue. That means that this tissue is found where? The name tells you guys, on the mucosa. Hence the name mucosa associated lymphoid tissue. So these ones, the 1, 2, 3 that we're going to talk about, they're found where? In the mucosa. If you look at it, let's look at a blood vessel, right? Or intestine. This is actually the intestines. So the outside of the intestine, right? I'm sorry. The inside of the intestine is lined by a mucosa. That's where they're going to be, on the inside. So mucosa-associated tissue, you have the Peyer's patches, the vermiform appendix, and your tonsils. Okay? You guys know your tonsils, right? What are the tonsils do you have? Come on, guys. What tonsils do you have? What are those? Mouth tonsils? Pharyngeal tonsils, right? You have pharyngeal tonsils, you have lingual tonsils, right? The different type of tonsils. We're going to talk about those. And then finally, you have your encapsulated lymphoid organs. They're encapsulated again because they have a capsule. That's why they call it encapsulated. So they're going to be your lymph nodes, your thymus that we talked about already, you saw, the spleen, and of course the red bone marrow. These will have a capsule. And that's pretty much a summary for the lymphatic system, that they are two semi-independent parts. So here you have your lymphoid organs, which is all in red. And you have what? Cervical lymph nodes, your thymus, your lumbar lymph nodes, your spleen, your pelvic lymph nodes, axillary lymph nodes, inguinal lymph nodes, right? All those. You have your lymphoid tissue, and you have your lymphatic vessels that you can see there in that image. Here's the true order of the lymphatic vessels. So we have about jugular trunks. There are two jugular trunks, right? What are the jugular trunks? Where are they found? Where are the jugular trunks found? Near the jugular vein. So most of these things, the name tells you what it is, right? So you have two. That means you have one on the right and one on the left. Subclavian trunks means that they're going to be where? On your subclavian vein in this case, right? Bronchomediastinal trunks, that means they're going to be somewhere in your bronchioles, right? Somewhere in your lungs, right? Close to your lungs. You're going to have two lumbar trunks, means they're going to be where? In the lumbar area. And then you have one intestinal trunk, means it's going to collect everything from your intestines. Clear enough? So if we look here, we go from the lymphatic capillaries, okay, all the way to small lymphatic vessels. We continue all the way to lymphatic nodes, and these are spread all the way throughout, right? And then from those nodes, we go to the lymphatic trunks. From those trunks, we go all the way to collecting ducts. Okay, and of course you have two collecting ducts, right? 9 lymphatic trunks. You see that? You see the number here? Do you really need to know the number? No. All I care is that you guys know the order. Okay? So you guys understand is that you're picking up the interstitial fluid, putting it into your lymph vessels, putting it all the way up into your venous blood, return to the heart. And then that's going to be pumped to the whole circulatory system. Okay? Do we have time? Or are we done? We got time? I don't know. My alarm just went up. That's weird. I thought it was already classes finished. I don't know. All right. So lymphatic capillaries. So next thing in the lymphatic capillaries, we're gonna have. Well, we're actually looking at the microscopy of it, right? So we said that the lymphatic capillaries on this side, right? They're kind of small and they're embedded in between the capillary networks of the circulatory system. So what makes them? What structures? What physical structures do they contain that they allow to pick up that excess or that extra amount of 15% of extracellular fluid, right? Interstitial fluid. So what qualities do they possess? Well, the first one is they have blind-ended capillaries, means that they end blindly here. Okay, they don't connect to anything else. The next feature is that they have a large diameter and thinner wall. Who has a large diameter and thinner walls? The what? So they got structures just like the veins. They have remarkably permeable and they're flattened. All right? So permeable and flattened means that they have high amounts of or huge amounts of what? Sinusoids, right? Huge size of sinusoids. Flattened because they're just flat. The next feature is going to be the mini bulbs. What is a mini bulb? The mini bulb is this features right here. You see there's a little bulb here that is created. You see that there? So there's an opening in between. So those are known as mini bulbs. Who has valves? Veins, and they're unidirectional valves, right? They actually can withstand high amounts of pressure, and they are going to remain open. That's a key feature. What does that mean? Look, what you see here on this image right here is that you have each one of those is a cell, right? And what I'm drawing in between here, that is the interstitial fluid. As that fluid keeps increasing, what's going to happen to the cell? The cell is going to try to get pushed around, right? Because you can have space now for the fluid. That does what? That increases the pressure in the overall tissue, yes? As that pressure increases, this tissue will push on this wall, okay? And the fluid will tend to go inside, right? Through that mini valves. And that's how it's able to, in a high pressure environment, so when there's a lot of fluid there, remember we said 2 to 4 liters, right? And in one day, when there's a high pressure in the tissue, these mini valves open and allows the lymph to, well, allows the interstitial fluid to become lymph and return back into your heart. So the next thing is it cleans and examines all cellular debris. This is important. Clean and examining. Who cleans and what examines? Well, the cleaning is by what? Having your B's and your T cells in there, correct? Because as this goes up, it goes through each one of your lymph nodes. Examine is, well, is going to be examined by any of your white blood cells, mainly your T's and your B's. So if there's anything that is a pathogen that is trying to enter your blood circulation through the lymphatic, then your body should be able to recognize it and at the same time, kill it, okay? So here you can see the flap-like mini valves, right, that I mentioned before. So it has a one-way valves as well, right? So that's definitely a vein. So it shares that characteristics. So that means these valves are able to collect pretty much everything. Again, they have big spaces, right? Big sinusoids on them. Big gaps. So they're able to collect what? Solutes, proteins, and including what? Virus, bacteria, and any other parts of cancer cells and cellular debris. So they can like pretty much collect everything. It's not like the blood vessels, right? The capillaries. Remember the capillaries? Red blood cells are not allowed to get in, and proteins, like really large proteins, do not get in. Only few ones, right? But mainly none of them go in. This one's, yeah, everything that it went in, now it's cleaning it up. And it's taking it back. Why do we say cancer cells? Well, cancer cells, your body recognizes as being something foreign, even though it's your cells, but it just loses, it loses that tissue recognition, okay, when this becomes a cancerous cells. So when we looked at lymphatic vessels, or actually lymphatic vessels, you can see the mini valves here, and this is an electron microscope of it. Can you guys see it there? So that unidirectional valve, the one that we're talking about. Whenever you're looking at the whole out of tissue, what are the things that you have to think of? Well, you have to think that there is always a what? Lymphatic vessels, because lymphatic vessels are pretty much everywhere. We said that for every artery you have about what? 2 veins, right? Well, there's a lot more lymphatics, capillaries, and vessels than actual veins. So we have plenty. You have veins, arteries, and as well, what? Nerves. Why are we even talking about nerves? Because there's nothing to do with nervous system. Think about it. When you have too much fluid deposited in your tissues, right? What do you think is going to happen to all these things as the fluid starts to deposit? You're going to make the lymphatic vessels, hopefully they work, and they collect it back and nothing will be deposited. But if the lymphatic vessels don't work, everything is going to get what? Smaller, right? And that nerve, because you're going to compress it from the outside, and that nerve is going to be compressed as well. What happens when you compress a nerve? What do you get? A pinched nerve, pain. You get pain. So every time you have a lot of fluid in that tissue, you're going to have pain. Have you ever hit a leg or part of your body, right? And they created an inflammatory process, right? The inflammation. And that inflammation led to what? To pain on the joint or on that area. Has that ever happened? Why do you think the pain is there? The pain is there because there's a lot of tissue, there's a lot of fluid on the interstitial space that is compressing the nerve. Okay? That's the reason. Huh? How do you remove that? You don't remove nothing. You allow your body to return the lymph back. In cases that is extremely painful, this is mostly in burn injuries, circular burn injuries. So if you have a leg and you burn it all around it, that scar tissue, as it becomes scar tissue, fibrous tissue, will compress the whole limb, right? At that moment, your body is creating even more fibrous tissue, so it's compressing more. Like you're putting a belt on it and you keep pressing on the belt, like keep pulling on the belt. And that moment, you have to take out the debris, which is case the fibrous tissue from the scarring, so you can let the lymphatics do their job. But most of the time, you let your body do the job.
But like, what about like in physical therapy?
Physical therapy, all they do is allow the joints to move. They give tissue massage, so that can increases the lymphatic return and blood flow to the area. But in physical therapy, you're not opening a leg.
Yeah.
You're not cutting any tissue.
I was just like wondering, like,
as far as I know.
As like massages. Like,
yeah, as you do deep tissue massage, then you actually are stimulating this fluid, this interstitial fluid, to be collected furthermore into the lymphatic vessels. And after a deep tissue massage, you should get some sort of inflammation afterwards, right? But this just to promote, is to stress the tissue and at the same time to promote the collection of the fluid. Next, we're gonna have, well, if too much fluid on the interstitial, we call it what? Lymph edema. So lymph is the lymph fluid, edema means inflammation, right? So that's lymph edema. When this edema becomes so massive, okay, this can actually lead to something known as the compartment syndrome. What is a compartment syndrome? Compartment is a chamber, right? So that means that a portion of your arm or your finger or your leg is not crushed. It's actually from there on, you're gonna have a massive inflammation, and that pain is from 1 to 10 that you're dying, that you're dead. It's about 8 or 9. So it's really, really painful. So that's compartment syndrome. Okay? It compartments a portion of your body by compressing the nerve and everything else in it because of increase of interstitial fluid that is not returned back on the heart due to the lymphatic vessels abnormalities. You also have something which is blocking the lymphatics. Most of the time is a viral infection to your lymph nodes. If your lymph nodes are occluded, then as you can think, right, as the lymph vessels returns the lymph from the lower or upper extremities, and they encounter a lymphatic node that is occluded, then the lymph cannot move forward, correct? At that moment, then from there below or there above, the lymph cannot return to the heart, so that extremity will be huge. You can Google it now. Google elephantitis and put the images. You're never gonna forget it.
Oh, is that when they're like...
Look at it, Google it, I'm not kidding you. So it's about 120-pound individual with a leg that is about 100 pounds. And that's mainly fluid.
That happens a lot to like people who are overweight as well, right?
What are we doing now? We actually have a table and we're gonna compare all the things and the features that we went over. So lymphatic vessels, right? They take blood to the heart. They're deep and superficial. Who's deep? Arteries. Who's superficial? Veins. So that means they do what? Both things. The next one is the pressure. Do they have high pressure? No, only arteries have high pressure. Everything else is low. Does the lymph has a pulse? No, the only thing that has a pulse is what? The arteries. Everything else does not have a pulse. Muscular wall. Well, which one has the pulse? Oh, which is the one that deals with high pressure? The artery, right? So that's the one that is going to be thick, right? So most of the other ones tend to be kind of thin. Nutrients. Nutrients, you're going to have nutrients from the branching of the veins of Azorum. Do you have semilunar valves on the veins? Yeah, these are the unidirectional valves, and you have valves as well on the lymphatics, right? They're the ones that we call mini valves, right? What are they going to do? Well, this one is carry the 15% that was left off from the blood capillaries, right? The 85 that's being collected. So that's a comparison table. Now let's talk about the major lymph collecting vessels. We said that there's two major ones, one on the right and one on the left, right? The main one of the two is going to be the left thoracic duct. This is going to be the most important one, right? Well, let's go over the whole thing again. So we have lymphatic capillaries all the way to what? Small lymphatic vessels. Then you have the trunks. Then you have the lymphatic what? Ducts. Okay? So those ducts can be one in the right and one in the left. The left lymphatic duct, which is the left thoracic duct, okay? It's going to collect all the lymph from a structure known as the cisterna of Kylie. The cisterna of Kylie is going to pick up all the lymph from both the right side and the left side on the lower body. Let me give you an image of that. So you can see here, right? You have a right lymphatic duct and a what? And a left thoracic duct. The left thoracic duct is picking up the lymph from that cisterna of Kylie. Okay? Remember, this is the major one. So, what does that even mean? Now, here, if you watch on the top right-hand side, you see that the right lymphatic duct drains only what? The right portion of the face, right upper extremity, and all the way pretty much up to the belly button, right? Just on the right side of the body, upper. Now, the left thoracic duct, which is the one that uses the cisterna of Kylie, okay, is going to drain pretty much what? The left side of the face, the left side of the upper body, and it's also going to affect both the lower extremities. You can see now the right lymphatic ducts, which is again the right side, and the left thoracic duct, which is all the inferior aspects of the body. Correct? Now, how does lymph get transported back towards the body? We said that the venous blood was transported back towards the body, right? The unidirectional balls, the muscles, contractions of the skeletal muscles. So there's going to be some sort of the same or similarities in here. So the first thing is going to have a milking action, which means what? Contraction of your skeletal muscles. Did we saw that already? Yeah, but we saw it on the veins, right? So that's similar. We have pressure changes in the thorax during breathing. Did we saw that already? We did. So that means that every time you breathe in, you create a negative pressure, and that negative pressure is going to pull the blood towards the thoracic cavity. Okay? The next thing is that we're going to have The next thing we're going to have is the valve that are going to prevent the backflow. Okay? So you have some sort of the way mini valves, kind of like unidirectional valves, right? Just like the veins. So far, 1, 2, and 3 are pretty much the same thing as the venous system, right? So hopefully that's not something new that you need to learn, because we already learned that. The only two new things is what? Since they're really deep, just like the arteries, then the pulsation of the nearby arteries as well is going to help with this. So imagine you have an artery on one side, an artery on the other side. As they pulsate, they're going to compress to the middle, and it's going to push the fluid overall to the top. Okay? The last but not least is the contraction of smooth muscles on the walls of the lymphatics. So yeah, they have smooth muscles. So they're able to constrict, okay, the lumen. So all these is a way or mechanism that the lymph uses, the lymphatic vessels uses to transport the lymph back towards the heart, into the right or the left thoracic duct. Okay? Now, why so important? Well, apart from collecting the interstitial fluid, right, making it a lymph, you also are collecting waste from it, right? And not only waste, within that waste, right, most of the time that you have an infected organism in your body, how do you acquire it? You acquire most likely, most of the time, from either your skin, because you break the skin and that bacteria get in, or virus, or you get it through your respiratory or what you're eating, correct? Sometimes you can get it from your eyes, but you have tears, and tears protect you. If you have any foreign object in your eyes, what is it going to do? You're going to start to do what? Cry. You're going to create tears, and the tears is going to pretty much clean that away. So most of the times you get infections from a rupture of your skin or your respiratory or your digestive. Now, in this case, as this bacteria or virus gets all the way into your cells and starts to invade the cells and kill the cell, it's going to leave something known as the antigen. What is an antigen? Antigen is anything in the body that is perceived as foreign. Means it's not part of the body. So if it's not part of your body, would you like it? Well, it depends what accessory it is, but no. If it's not part of your body, you don't want it inside your cells, right? You don't want it near your cells. So that means either bacteria or even the toxins, viruses, right? Or including mismatch of red blood cells will be qualified for being what? And you need to do what to the antigens? Destroy them. So what are some other things that are antigens and we don't see it as antigens? Okay. Foreign proteins. Is your bacteria made out of proteins? Yeah. I mean, your cells are made out of proteins, right? Bacteria are made out of protein. Viruses have proteins. Nucleic acids. Where do you find nucleic acids? On your DNA? That means that, does the bacteria have DNA? Hopefully, yes. Everything has a genetic code, right? Viruses have genetic DNA? Yes, they have a genetic code. So nucleic acids. Lipids. Did you have lipids embedded in our cell membrane? So bacteria will also have some sort of lipids as well. Large polysaccharides. And these are actually part of the capsular structure of the bacteria. So these things are also known as antigens. So an antigen, if you look at it, is like us. We all are the same, right? We have 2 eyes, 1 nose, 1 mouth, 2 ears, right? 1 head. Does that make sense? But now, does that mean that we are all equal? Do we all look not equal? We are all equal. Do we look the same? No. I mean, we look similar, but we're not the same. So that means that each antigen will have a 3-dimensional structure. That even though they are similar, they're not the same. That means that every time we talk about the T cells, the cell-mediated, needs to recognize the cell. If we're talking about the B cell that needs to create the D game, the immunoglobulins, D, G, A, M, and E, they have to make one specifically for what? For this antigen right here. Does that make sense? So you need to create something that is three-dimensional and can bind to that antigen. So here you go, one more time, the lymphocytes. So you have your T's, T cells about 80%, B lymphocytes about 15%, your natural killers, which is your immunosurveillance cells, are about 5 to 10%. We already know that the T cells are born in rainbow marrow, and they go to school all the thymus, right? That's where they become immunocompetent. If you don't become immunocompetent, what do you get? You get death. That's what you get. If you don't mature the way you're supposed to, the body's going to kill you. Okay? So overall, they make up about 80%, right? Now, there are three main types of T cells. We have the cytotoxic T cells, the regulatory cells, which are the helpers or suppressors. So T helpers and T suppressors, what they do is they regulate the functions of other cells. The suppressors, what they do is they inhibit the function of T's and RBs. Means if you have too many T cells working in one location, what do? You send a suppressor, and the suppressor says, you know what? Stop. Because too much of this can lead to an autoimmune disease, right? Or it can lead to excessive amount of tissue damage. And you don't want that. The next one we're going to have is your memory T cells. And the memory T cells, right? Well, they make what? Memory. Means as you grow older, or as your body grows wiser on antigen exposure, your body will make a copy and will remember what antigen you had before. So next time you get exposed to the same bacteria or same virus, same antigen, what is your body going to have already? An antibody that is going to automatically do what? Find it and kill it. At that moment, if you have the memory, would you have any symptoms? Would you acquire any symptoms? No. You're going to have no symptoms. Why? Because you're not going to take any time. You're not going to allow that bacteria or viruses to enter your cells and start killing a bunch of cells and a bunch of tissues, because that's what gives you the symptoms. Okay? So most of the times, if you have memory already, you're not going to feel a thing. Right? Now, how do we do memory? Well, we already said that the T cells are created on the bone marrow, and they go to get mature at the level of your thymus. And the thymus, as we say, we go and they become immunocompetent, right? So there are three fates of this. And the fates are the following. The first thing is your body's extremely smart. Instead of putting the T cells all the way in the body, and if that goes good or comes bad, then you're killing part of your body. Do you want that? No, if you're killing parts of your body, that means that's known as an autoimmune disease. So the nice thing about it is that it sends the T cells only to the thymus. So if something goes wrong, what tissue is going to get damaged? The thymus. And that's why when about you are 35 years old, about 30, 35 years old, your thymus is completely what? Disappear. Why? Because you're constantly fighting to find who is the best match. And in that, well, you have some sort of attack and some sort of death, right? And at the same time, as well, right, you already have got exposed to the majority of antigens that are around your area, so you don't need any more memories. You're good with what you have. Now, if your job depends on flying and going to different countries and different places, then you always will get exposed to what? New antigens all the time. So your thymus will be kept. Does that make sense? As you get older, what happens? You get more localized, right? Like when you're 45, think of leaving your house and leaving things like that. Most likely, as we grow older, we get accustomed to the area that we live on, right? We make a bigger change, but then we stay in that area. And that's what is happening here. You don't need it. You already have the antigens. unless you have a lot of influx, right, or efflux, right, a lot of influx of population, so new people coming, which is nice here in Miami, right? We got that, so our thymus should be big or still be alive when they're 35 or 30. So what are the process? So as the T cells goes from the cortex to the medulla, at the level of the medulla, that's where they become immunocompetent. Now, if your thymus cells are recognized by the T cells and they love it so much, so they have a positive selection, they bind to you and they squeeze you really, 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 really tight until you die. Do you want that? No. So you eliminate it through a process known as apoptosis. If your T cells is an immature, right, incompetent cell, it goes to the thymus cells and it says, are you part of my body? I don't know. That means it fails to recognize that that is your cell. Would you want a cell like that? Dude, it's not recognizing your cells, so you don't want to keep it. Okay? Which is the ones that you keep? You keep the one that is able to recognize your cell and at the same time say, hey, you're my cell. Let me see what's going on there. Does that make sense? Because now you recognize the cell of your body, but you're willing to kill the antigen. Yes? And that's the one that we go from positive selection. If you bind too tightly, what do you do? If you bind too tightly, you get something known as what? Autoimmune diseases. So, you know there are people that have autoimmune disease, right? Have you ever heard of lupus? Lupus is an autoimmune disease. So that means that something went wrong here. Right here. Something went wrong. So that's an autoimmune disease. So that's what your body does all the time. So what are the autoimmune diseases? Just an example. So if we talk about the thyroid, then you have thyroiditis. In this case, it will be Hashimoto's and Graves. If we're talking about the bone, then you have rheumatoid arthritis. I'm pretty sure you guys know somebody about rheumatoid arthritis, right? Ankylosing spondylitis. This is bad. This is a 20-something-year-old individual, 20s, mid-20s, early 30s, that, or even teens, like late teens, that they need to work out, like run or do some sort of exercise in the morning, because when they wake up in the morning, they feel like they're 90 years old. And as they start moving, they get better, and that's how their day goes by. That's ankylosing spondylitis. Polymyalgia rheumatica. It is actually pain, a lot of pain. Rheumatoid arthritis, ankylosing spondylitis, and polymyalgia rheumatica. Skin, psoriasis. Have you ever heard of psoriasis? The one that gives you that flaky white plaques? Vitiligo. People that have the white patches in their skin. Eczema, scleroderma, pigmentosa. So all these, right? Fibromyalgia, Wegener's granulomatosis, neuropathies, diabetes, celiac, Crohn's disease, ulcerative colitis, diabetes type 1. All these things tends to be what? Autoimmune disease. So that means that your body failed to properly select, right, who was immunocompetent. Now, autoimmune disease prevalence. Prevalence is the amount of individuals that have the disease, right? They're still alive and have it. So within the United States, it's about 5.9% of rheumatoid arthritis. That's a lot of people, guys. In the whole United States, 5.9%. Is that over 10,000 people? Yes. In the whole United States, that's a lot of people. And then you have psoriasis. So there's a lot of people, right, with this, the affection. Now, American living with autoimmune disease in millions. Millions. 1.5 million. Lupus. Is that a lot? That's a lot. Crohn's disease. You guys know what Crohn's disease is? Lupus is an autoimmune disease that pretty much gives you some sort of like causes discoloration of your face and skin. It's an inflammatory process around the whole body that only affects the skin, but actually affects the muscles and everything else. Crohn's disease. Crohn's disease is actually a malabsorption. That means your intestines will be inflamed. If the intestines are inflamed within it, can you absorb food? No. So these people suffer from diarrhea, suffer from constipation. I mean, it's a mission every time they eat, right? So you have to be careful on what you really eat. Rheumatoid arthritis. This actually affects the what? The joints. Who has rheumatoid arthritis? Look. Rheumatoid arthritis, 1.3 million. Rheumatoid arthritis is found on young females. The predominant, right? That's, yeah. Young females, 20s, 30s. That's when they wake up in the morning, their joints hurt like crazy. And as the day goes by, it gets better because it's an inflammation at the level of your joints. Whenever you have a joint inflammation, they hurt, right?